So as we know, glaciers are melting all over our planet and rather faster than we even anticipated. So I'm going to tell you about our National Geographic Explorer project to investigate the behavior of these glaciers to better understand how they're melting and how they're changing. So we did this experiment in Iceland, on this huge ice cap in Iceland. We chose 2 adjacent glaciers so that we could have them in a similar environment, but as we'll discover, they're very different glaciers. One of them is called Breidamörkajökull, and the other one is called Fjalsjökull. So I'll just call them Breda and Fjals. Fjals is kind of a nice place to work because the vegetation has carried on growing there as the glacier has left, very often sunnier, and we do things like fly quadcopters there. We took this nice time-lapse video using a camera we left there so we could get a feel for the amount of ice that's carving off of the front into this lovely lake, and that definitely affects the way that the glacier melts. So as you can see in this blue area, after a few years, the ice really has melted back many kilometers. And what will happen over time, we predict, is that all these little lakes will grow and coalesce into one huge lake, which will just cover the entire front, and you won't really be able to see any of the old features. So one of the parts of the project is to record those features for posterity, as it were, as well as monitor the glacier change. So in order to do this, we use things like quadcopters, which you can fly up and down and take gigabytes of images. And after a week of processing on your PC at home, you get these beautiful 3D models, which show stones and a very good record. This looks like I'm flying a quadcopter, but this is actually me just flying with a 3D mouse through the 3D model. So what we're seeing here is how detailed a model you can create if you spend all day flying a quadcopter up and down. So Breda is a worse place to work, very often colder. You can sink up to your knees in really gloopy mud, and you can see us here desperately trying to work under orange rain covers to place our equipment. But this one similarly has had a massive melt back of ice of many kilometers over the years. The little dark bit in the front is where you would visit if you went to Iceland. You would go and visit this beautiful Jökulsárlón lake and look at the lovely icebergs in front of it. So in order to measure the flow of the ice, we actually generated our own design for a real-time kinematic GPS system, which would send data back to us every day about the motion of the ice, which is really exciting to see. Every day you get an email. So this is the box as we packed it up to take to Iceland. There's this tiny little computer running MicroPython, which controls the GPS, which actually is a unit from Swift navigation in San Francisco. And it sends the messages using Iridium. So in Fjalsjökull, you can see the gray line here is the temperature, and you can see these spikes of movement, even in the winter. So the glacier is occasionally surging forward, even when it's winter. That red line is Breda, and in the winter, it's very, very dormant. At the moment, it's flatlining on all the data that we get. So this poses a really interesting question. Why do they behave so differently? And that's obviously a research question that's going to happen for a while. But here's a nice time lapse we did of Fjals over winter, and you can actually see the ice moving. It's really nice. So this gives us an impression of how much movement there is there in these cold conditions. So what is causing this behavior? This is one of the big research questions at the moment. Clearly, they have different water systems underneath the ice. They have different conditions underneath, so that the bed of the glacier really does affect the flow a lot. One of the other things that affects the flow is this huge lake in front of the ice. That almost draws the ice into the lake, and so that has a big effect there. To see whether our sensors were being affected by this draw into the lake, we moved one across, carried it across. Luckily, the equipment's quite light. And the data actually looked very similar to what it was before. So it wasn't that was a big change. So this area needs a lot more study. We've left behind lots of cameras to record what happens over this winter, and we'll get that data next year. To build up a better picture to help us understand the behavior of these two glaciers. So the tale of these two glaciers is not over yet. We will be back with more instruments. We've left lots of instruments. I got an email today from them saying how much data they'd sent me. And this is to better understand how they're melting, how they're changing, and how they're flowing in the future. Thank you.